Okay. Okay, we'll start the meeting. Uh, you can see my screen, right?
Yes, yes, sir.
Okay. Last time we had done this connection, we didn't receive the backend plate, so we will get into that connection and I'll show you why it is not coming. Okay, create a project. See, when you had tick this one, backend plate, there is an issue. This is not coming because the backend plate will come. Backend will plate will come up to the normal plate. See this plate up to this height. Has to come. It will come. So if it has to come, there is an already first operation stiffener is there. The stiffener is clashing with the backend plate. So that is the reason it is not coming. So if you remove this stiffener and then if you take this backend plate, then the backend plate will come. So but you need to stiffener that location. How you can do that? So the thing is you have to repeat the operation after this operation. After end plate operation, you have to do this stiffener operation. Then it is not a big deal. So this is only problem. There is a backend plate passes through the stiffener. So you can modify the stiffener. Otherwise, you can modify the backend plate right now to reduce the size of the backend plate. Like you can give minus 30 plus 30. Now it is not clashing. So both warnings are gone. So the operation sequence to be followed. Then only like this errors will come. Otherwise, then only we can get the connection correctly. The sequence only sometimes problem. So this is finished right now. So backend plate is coming. Okay, I will go for another connection. So one we had explained already the beam to column. Then we'll explain to beam to beam. That also almost similar. Okay, we'll explain with the this is thin plate and shear connection. I will explain on shear connection or one moment connection. One moment connection. I go with moment connection. We need two members. One is bearing member and one another one is some loading member. So loading member which we are setting it as a loading member. So here you need to check the rotation of the beam. This beam you can change the rotation to any degrees like I already explained in this angles, beta angles. Then it can come to load cases. This is same. Here right now you are taking it as a loads in equilibrium. So if you take it off, only loads in bearing loading member only you have to give. Okay, then what are the operations required? This one for stiffener one. For stiffener one, you stiffener same operations what we had explained in that in a column position also same. Then go to stub. This stub operation is we are making it is a stub connecting to the member, but they are calling it is a stub, but it is not a see they are connecting between one more stub here. That is the reason they are calling it as a stub because it is like a splice connection between the beam to beam. It's not like complete connection. But we can have another connection like another operation for the connection but like this connection stiffened end plate. So for this one you have to remove this cut you remove this then there is an operation like stiffened end plate. This is also a moment connection. This is same as previous but here only there is no another member. This is directly connecting to the plates are directly connected to the member here. But in previously one member is connecting and then it is connecting to the this member. So for this one you have in these operations are like one stub plate like one stub beam will have to select the position the B1 and have to select with position, and at which position you want to say, at which time position you need. Like X position means if you change this one, this position is changing, it is moving in this direction to get the plate in different at different length. Actually, that is the thing. So you can have like 300 also fine. And next thickness of the plate is this two plates, or which is going to bolted two plates. So two plates are 10 mm thick plate. Otherwise you can change and check two plates, these two plates. And same thing, it is bolted connection. And top I want, they are given minus 5 mm to weld it like this. We can have plus 5 also like this. But problem is why we need to give only minus 5, because if we have another any other operation on this beam, it will clash. So if you don't have any other operation, then we can have like this. If you have any another issues like the grating will come, then this is not possible. So you have to go either by 0 or either by minus. Either if you want to go with 0, you should go with bevel weld. So you can go with cutting, or others you can go cutting with the bevel cutting in the member also. You can cut in the member, then you can weld in that groove. How can we cut in that member? Then we can have a cut in the editor also. You can have a cut. This is for plate only. Okay, in this member you can have some cut actually. Mm, can cut. This will not work. Okay. Okay, I think right now we can't have the cut in this member right now, but we can have, it can show like that how we can give the weld in that position. But okay, uh, for this stub operation, remaining things are bottom. Bottom we have like 55 mm. It is extended to weld with this uh, flange plate. That is the reason they had given this 55 mm. And bolts, number of bolts, same thing, bolts will be say anywhere it is same. Can have the you already selected here the bolts to profile. That is the reason it is coming in four ways, four dimensions. And if you give only profile symmetrical, it will give only two. With rectangular means it will come all dimensions you have to give, and then only it will come. If I give 100, same it is explained in the same with column also. So the same thing will happen, then only it will come. Then I'll automatically bolt whatever we give here, it will come. So you can go with the profile itself. Then go to bolts M24, whatever the type you can select is similar as previous. So the remaining things are almost similar, nothing else. Just only thing is stub what we had selected here. The stub we can have any profile what we need, we can have that profile based on here. We can select it here. We can select another profile also. application got terminated. Both connections are there already. So yeah, in this connection, there is no member here. Here uh, only plate thickness and how you are going to give the play bolting to the profile or to plate profile symmetrical height automatically. If you height automatically, then automatically the height of the members plate will be adjusted. Otherwise, you want you means you can adjust this like this. So if you don't want like that means you can adjust automatically the plate will be adjusted to the plate to the profile itself. Next, beam and plate. This is also profile symmetrical. If you give only to profile means it will come only to the profile or then you can give the remaining dimensions how we need. How you can get like this plate is changing. Like that. This is just completely trial and error. How can see where it is changing. And then if you require that one, you can change that values. Next, stiffener. Stiffener which is connecting inside the beam. This one. Stiffener. This dimensions and the thickness of the stiffener and chamfer edges. If you need chamfer edges, you can have. Otherwise, you know means you can have the chamfer cut. We can mention that might be 20 or something. Or if you have more also, it will increase like that. So next bolts. The bolts what you are seeing is the M24 we are using. Now top layers we are having only one layer. If you want to have more layers, you can have. Otherwise, you have selected profile symmetrical. That's why it is coming two times, two bolts once at a one time. So if you select profile, you can have only one. So like that we can change. Next, bearing tension, which how we are going to transfer the forces. We can select that, and then shear plane in thread or not. This is will be in thread only. So we can have flanges, welds, then stiffener, back stiffener if you want you can have. Otherwise back if you have another member like if you now after selecting the connection if you have some other member is connecting how to add a member go to the members select here you can copy this copy this members copy then one member will come if you come copy this b1 this another member will come so if it will come at exactly same as the same position same things but if you need this position to the name the another this side means you have to change this location this angles like this. Like this you can change this and you can find what is happening then you can get the member as you wish. So now the stiffener is clashing so you can have the stiffener and you can have the connection how you can get the connection for this member so you can have in operations you have to add an operation to this member then you can get the connection to that so go to the operations how you want to get the operation which operation you want to add you can see these operations which is similar to the your connection you can have that operation like we can have same connections different end plate if you don't want to do it again you already made keep everything correctly and then it is another member which is going to come is the same profile same beam same profile means you just copy this scp1 copy this scp1 then only all parameters from that scp this one it will copy to this one so after copying there you can select to the B, it is member to which it is different. So you can select member M3, then automatically beam everything will be changed, welds everything. So we can run the analysis now. That's all. It's finished. Now the connection is fixed. Like this, we can have n number of beams and we can have n number of connections, n number of operations to do this. Otherwise, if you want to do only with welded, where one is welded, one is bolted, like you can have like that. That also here you can put that is welded. That is can be done. So simple. There is only one location change. That's all. Okay. So we can go with another connection. Like in this beam to beam, everything is finished. Then we will go for column to base plate connection. Base plate connection. In this base plate connection, I'll select this. We'll go like this. In base plate, here if you go to the operations, it will be welded. Base plate will be connected to the concrete. You all know already. So whenever it is connecting to the concrete, you should check the concrete parameters, like concrete breakup should select cracked concrete. You should select this option because it should check the concrete also. Generally it is selected. If it is not useful, no issue, but if you are doing with concrete, you should check with that. Sometimes we are not going to design the concrete, but that in that case you can take it off, then we can make it pass, because concrete they will take care, like they may have some more tension rods or some other things, maybe they can have some you see this water to cement ratio, otherwise they can have some steel extra, like that. So that concrete part they can check, right? So we can do the uncracked concrete, like we can take it out and then we can do work. We can do the work. I mean they may design the connection. Similarly here, and the base plate parameters, like we should select the member to which we are going to put the base plate connection. So we have to select that member, and that if the same base plate we can have another member also, we can design like that, but the thing is only one connection will be designed here, like that. So this is plate thickness which we are going to use. It may be 20. We can have the profile symmetrical or profile. So we'll go like profile symmetrical only. Next, top how much we need, bottom how much we need, like we need 200 by 200, like this. We can have coordinate system from member, otherwise from the global coordinates also we can take. Allow the dimensions input mode to be rectangle. So global dimensions will be allowed for only for the rectangle. Okay, from member we can select. Then orientation. Orientation can be changed, like the plate orientation only it is changing actually. So whatever it is same. The rotation decrease if you give, then it will rotate. See, like this. Now M24, an anchoring length. Anchoring length is like how much deep that it has to go inside the concrete. You can see here this is a 300 what we are talking about. This 300 can be anything like 200 something, whatever as per your specifications. And you can have a straight, or otherwise you can have it washer plate, rectangular, circular, like this. And size of the washer plate, this was you can be having 50 something else. And the top layers, number of bolts you need, as you can have like it is profile symmetrical, that's why if you give one, both sides it will come, like this. Both sides it will come, but this many bolts not required. If you don't want, you can delete it there, otherwise you can you, you can go with to profile. To profile is better because you can have only wherever we need. Nice. Next, the welds as same. Next, foundation block. A foundation block parameters like how much wide this one offset, how much offset to with the column. So it can be like 500 also, and depth 800. So this transfer, how we are going to transfer shear force transfer by friction or by you can have shear leg or anchors. We are transferring to anchors right now. Otherwise, you can have shear leg. Shear leg means there will be one more beam will be connected to this plate, that is shear leg. We can have that parameters, and which that parameters like what is the profile size and how what is the length of that shear leg and what is the position of the leg and what is the rotation of the leg. It can be 90 degrees to the column or same with column. Generally, it will come same with column. If you want to rotate it, you have to rotate it. Otherwise, you can go with column. And uh, this base plate will be rest on the with grout, so you can have it has directly standing on the this pedestal, or it is going to go with the mortar joint or gap. You can have some gap, or otherwise you can go with the mortar joint. Can give how much thickness of the mortar joint, can give 25 means mortar joint will be created here, so we can run the analysis. But in this, some may have stiffness. So how to get the stiffness? They may say there is a option like wideness here. Same, it's already added. Okay, you can select this widener. Then in this, how we need the stiffness, like if you want to add to all the sides of the member means you can have all parts. Otherwise, only you need only to the flanges means only to the flanges, or one side means only one side. If you want to add to all parts means in all parts, only to flange, only to the webs means only webs will come, and both means both sides will come. The dimensions of the stiffener like can be 200 means it is exceeding our plate, so we have to reduce that part like this. For this one, you can have chamfered edges, chamfered 30 by 30 like this. So the welds can. In the similar way, how you can have like another option like we had added widener. You can have also rib. This is also similar to this, but rib can come to the like, see rib is coming like this. Rib is coming directly on the web means it will come to join with the rib. So you can select with the flanges also this one. If you select bottom flange, see it is coming like this. So in the here also you are having in the middle same as like we have selected webs there, we are getting the stiffener there, and here also we are getting like this. So here you can select also both are only one part. If you select upper, only one side is coming. So one side is there, no issue. Next, after selecting this one, what is the dimension? And you can position those things. Right now we have repeat count 1. So if you have 0 means only 2 will come. X position. You can select that position like where you want it. This is the position where exactly it is coming. 100 mm from the flange, like flange edge. So that is the reason it is coming here. You can have that, but both will change at the same time. So if you don't want like that, you can go with wideness. Otherwise, you can copy this operation n number of times to get used like that. If you go here with the 2 count, then one more add will add. here see add first means if you have this option you can have another, otherwise no need. With only two you can go with. So if you give one here, only one is coming. So that's all. Like this, we can have as many things, right? So this is one operation you can do with columns, the space plate operations, and um, see these all operations you can do with anything which is suitable to that connection. Then only we can do that. One is operation is like cut of the member. So whenever the member is directly welding to the another two members, they can be having cut between two members. This is adding a stiffener in the beam. You can have the stiffener at any place. And this is wide neck, which I'll explain right now. And this is rib, which is explained. This is a opening or notch. I think how you can have like this. You can see opening or notch. So I want to have it member flange and to shape it as a notch. Uh, Location front. See this notch is happening here to the member to BAM lunch. So which member you have to select. If you don't have any idea, you can select this arrow button and select this. That's all. Now you can see how the notch is coming. Notches happened like this. So if you don't want 10 mm but 40 mm is coming, it should be good the rounding radius. Hmm? See like this notches happened. So same thing before I told it notch in the beam to give the weld. Like this you can do this. Like this in this operation you can do that. And same thing this one end plate which you had explained in previous end plate. Now this is today it is explained stiffened end plate with the it stub also explained today. And next this is splice plate. Splice connection we explain splice two types. One is member to member, plate to plate. This is splice connection on the member with the flange to flange like that. This is brace connection. So in the remaining we have to check. Okay, I will do this two connections right now. Okay, and next you can have the bolt grid by our own also. I will show that also. Okay, another operation, another. Okay, for tomorrow, today it's closed. We can have tomorrow session. Thank you.